Okay, this is Stats260. We're looking at review 4. This is the last video I'll be making for you this semester. Hopefully, you've been able to follow along and have learned some stuff. This is probably going to count as the shortest test. There's going to be 5 multiple choice problems, just like on the last test. And then there's going to be basically 1, 2, 3 problems that you're gonna have to work through from beginning to end, and we'll take a look at those right now. All right. Oh, before we start, this is the last chance I have to get Star Wars trivia out to you. So I know a lot of you don't care about Star Wars, but this is you know, C-3PO has been my TA the whole time this during the online course here. So Stormtrooper, they're the bad guys in the old version movies, 4, 5, and 6. And on the back of their uniforms, they had this tube. And that was because in the original concept design, everybody was going to have a lightsaber, and including the Stormtroopers. And then he changed his mind, George Lucas, and said, no, just the Jedis will, and you know, knights like King Arthur, swords, and Jedi knights, right, from the King Arthur tales. So but they left that on the uniform. The little tube was supposed to hold the little lightsaber, but they got rid of the concept but kept it on the uniform. Okay, so that's it. Don't worry, that won't be on the test. That won't be on the test. So let's look at what will be on the test. The null hypothesis is mu is equal to 50. A type 2 error. Type 2 error occurs when, and it's choice C, deciding that the mean might be 50 grams when it actually is not. So let's think about that in generalized terms. That would be you're failing to reject the null hypothesis. If the null hypothesis is mu is equal to 50 and you're deciding that it is 50, that means you failed to reject the null, but you should have. You should have went with the alternative. That's what a type 2 error is. Number 2 says, suppose you're testing that same claim. What's a type 1 error? Well, a type 1 error would be B. That would be determining that the mean is not 50 grams, even though it is 50 grams. And so let's think about what that is in generalized terms. That is rejecting the null and going with the alternative. So we go with the alternative hypothesis, but we should not have. Determining that the mean is not 50 grams. So we reject the null hypothesis and conclude the alternative hypothesis, but you shouldn't, because it really was 50 grams. And so that's a type 1 error. And then they kind of continue on number 3. What's the symbol for type 1 error? That's alpha. And how can you reduce it? Well, the easiest way to reduce the possibility of a type 1 error is reduce alpha. So if you're really worried about a type 1 error, instead of having alpha set at 10%, maybe set it at 5%. And that will be the chance of a type 1 error. Whatever alpha is set at is the chance of a type 1 error. So if they say test this claim at a 5% significance level, that's alpha is equal to 5. If you are worried about type 1 errors and you want to reduce it, then you can reduce that from 5% to 1%. And then you'll have reduced the possibility of a type 1 error. So reduce alpha is one way. The other way, if you have the means, increase sample size, increasing sample size to a point. But in just layman's terms, increasing sample size will usually decrease the chances of an alpha. Now, why do I say usually? Because when you're getting into really super large sample sizes that are approaching like the population, then it won't really have a real significant reduction. All right. So, but in general, increasing sample size is usually a way. Most samples are, 500 or 1,000, or you're usually not talking about 50,000 to 60,000. So, okay, two samples are independent when the selection process in no way influences the other sample. Okay, so two samples are independent when the selection process of one sample in no way at all influences the other sample. All right, what is a statistical test? A statistical test uses data obtained from a sample to make a decision and so when we think about to make a decision to reject the null or fail to reject the null hypothesis about the population. So you use the sample to kind of make a decision to reject the null or fail to reject the null. Hypothesis, and that is usually then we're making conclusions about the big picture, the population. And so now for the next three problems, there's three problems on the test. There's 5 points for each one of these little sections. And so let's take a look at those. So the first page on this last test is going to be multiple choice. A student had asked, they're like, well, wait, I can try as many times as I want. So couldn't I kind of cheat it on the multiple choice by just trying until it says correct? It's not going to say correct. You just have 3 hours to do the test, and whatever you submit, it doesn't get corrected until I actually see what your answers are. And so, do you know what I mean? When you go in, and on some of them, I know on some you can on Blackboard make multiple choice tests where when you hit enter, it tells you if it's correct or not. And then that's not this one though. This is actually, I coded it as a short answer problem. So you could have A, and then if you decide that isn't right, you could change it to B. And as long as you're in the 3 hour window, you can change it as many times as you want to whatever letter you want, but it won't tell you the correct answer. So I'm the one who checks it. So keep that in mind. All right. And let's go through and do these problems. So there's A, B, C, and D. This is number 6. So officially, there's only a 6, a 7, and an 8, but there's 5 parts on each one of those. And so that's how we're going to break down the 5 points, 5 points, 5 points, 5 points. So it says the average production of peanuts in the state of Virginia is 3,000 pounds per acre. New plant food has been developed and is tested on 60 individual plots of land. The mean yield was 3120 with a population standard deviation of 578 pounds. At the 5% significance level, can one conclude the average production of peanuts has increased with this plant food or not? And so let's look at, so the null hypothesis, that means I did this plant food and it's still basically 3,000. The alternative is it's a plant food that's supposed to be increasing. So it's greater than. And so in the context of this problem, that means this is a one-tailed test. And we're going to shade the top part. It's going to be part B is, okay, draw a pretty picture. So you got the standard normal curve, and we've got some critical value. And it's got to be above that critical value in the shaded area. If it lands in this shaded area, we reject the null and conclude the alternative that it's more than 3,000. And if it is not, if it's in the unshaded area, then we fail to reject. So this unshaded area is all failed to reject. And just conclude the null, that nothing really changed. And the shaded area is reject the null. All right, so those two regions. So now, why? Some people are like, no, it's 3,120 pounds, which is more than 3,000, so the stuff works. So why are we doing this? Well, you see, the standard deviation, that's how much variation there is in a normal thing. That means we could get an average like this, the 3,120 pounds on 60, just by chance, because the standard deviation isn't zero. It's almost 600 pounds. And so that's why we're checking to see, is this significantly different, or could it just happen by chance? All right. And that's also why we set things like an alpha at 5%. So if we were worried about a type 1 error, then we would set this at 1% instead, or 0.5 of a point, like 0.005, half of a percent. All right, so let's see what they gave us. They gave us X bar, the mean, 3160, N was 60 pieces of data. They gave us the standard deviation of the population, so we get to use z-scores on this. And, we were given mu. The population mean is 3,000. So we got to see, is the new stuff better? So with the 5% significance level on a one-tailed test, we look up our z-score. And so here, I'm going to grab the chart and put the chart in front of you. I'm not going to do this every time, but we're going to do it for this one. So here's our chart. Oops, I got to get to the right one. All right. So we have a one-tailed test, 5%. And you want to follow that all the way down to the z-score, which is 1.645. Okay, so that's our critical value. That critical value is 1.645. That is a z-score, but a lot of times in the work, I'm going to just call it CV. That's our critical value. So we have to do better than 1.645, and that'll put us in the shaded area, and then we reject the null and say, yay, plant food works. If it is not bigger than 1.645, then at a 5% significance level, we say, yeah, it really didn't do it. It wasn't significantly different. All right? So let's continue. So now part C is find your z-score. So that's going to be X bar minus mu over the standard deviation of the population divided by the square root of n. Remember, it isn't for the entire population. We're testing with a sample size of 60. So that's going to change our standard deviation. The standard deviation of the population is 578. But with the 60, we got to work that 60 in there because you're now looking in a smaller pond. So there won't be as much variation because you're only in a sample of 60. All right. So we got 3120 minus 3,000 over 578 divided by the square root of 60. You might want to do this in two parts in your calculator instead of trying to get it all in once. Where you write down the 120, you do 578 divided by the square root of 60. You get 74.619. And then when you divide that out, you get 1.608. We needed it to be bigger than 1.645. It's 1.61. Close, but no cigar. So this, doing red, that falls in the unshaded area. Okay, so that means, what does that mean? Well, that's the fail to reject area. So that brings us to letter D. Should we reject or fail to reject? We are going to circle the fail to reject. So this, we could either circle reject or fail to reject. We're going to circle fail to reject because it's in the unshaded area. And now, which one does that mean? That means we're going with this is going to go, this is the one that we're concluding, that the mean is 3,000. So we say E at the 5% significance level. And now we need to put it, that's the mathy part, get the, at the 5% significance level out of the way. We conclude, and now I want context to the problem, to the actual problem. So we conclude the average production of peanuts in the state of Virginia is 3,000 pounds per acre. So the average production of peanuts in Virginia is 3,000 pounds per acre. So basically we were restating this null hypothesis, all right? So if somebody wanted you to break it down further, you would say the Miracle Grow stuff, the new plant food that you used didn't change it significantly. There wasn't a significant growth, all right, at the 5% level. Okay, let's make sure. All right, good. You could read everything. All right, let's do 7 and 8 are really similar to this. So we got a school superintendent says that his new mentoring program has decreased the dropout rate in MPS to less than 15%. Random sample of 200 Milwaukee Public High School students, 21 dropped out before they graduated at 5% significance level. How should we feel about the superintendent's claim? Well, let's see. The null is P is equal to 0.15, meaning nothing changed. The alternative is that he actually reduced it. His new program reduced it. It's less than 0.15. So this again is a one-tailed test. All right. So we're going to draw a pretty picture, but this time the tail is going to be on the low end. our critical value. We're going to just look up our z-score for 5%. We get to use the z-test because probabilities. We get to use z with probabilities. So we got the critical value for 5% to be negative 1.645. We have to put the negative on there ourselves. You look up the 5% and it just says 1.645. But because we're on this end, we throw a negative in front of it. All right, so that's our critical value. Let's look at p hat. That's the sample. So p is the population was 15% dropout rate. That's got to be over time. And so p hat was this 21 out of 200, which is 0.105. But is that significant? Is like 11% drop from 15 significant at the 5% level? So we're going to find out. Well, we know P is 0.15. We also need Q for our equation, and that's going to be 1 minus 0.15 or 0.85. All right? So now Z is equal to P hat minus P over the square root of P, Q, all over N. Now, let me caution you. This is P and Q, not P hat and Q hat. Okay? So be careful about that. A lot of students last semester used 0.11 and 0.89 for P hat and Q hat, but that's not what the equation wants. It wants just P and Q. All right, so we go 0.15 minus 0.15 over the square root of 0.15 times 0.85, all divided by 200. And then after you do that, you multiply that times that, divided by 200, hit enter, then take the square root of that answer. So we end up with negative 0.045 over the square root of 0.00064. That is negative 0.045 over 0.02524. And so we're looking at a z-score of negative 1.78. So let's see, is that significant? Grab out the red marker here. Negative 1.7, this is negative, yeah, it is. It's in the shaded area. So z is equal to negative 1.78. And so that means we reject the null hypothesis and conclude the alternative. Remember, the shaded area is the rejection zone. The unshaded area is the fail to reject. So we go with this one. And now we write up. Oh, first we reject the null. So we circle that first one, reject the null. And then E at the 5% significance level, we conclude the dropout rate is less than 15%. Now, do not say, oh, it's 10.5%. That's what the new dropout rate is. No, this was based on a sample of 200. This was an entire population. All this did was you either state this, that it's still equal to 15%, or you state this, that it's less than 15%. That's why we write those down first. This is the information we use to make our decision. But the decision is either this or this. It isn't, now the new dropout rate is 11%. You'd have to do lots of studies to make that the new population dropout rate. All right? More than 200 for sure. Okay. And then the last one on the test. And while I'm erasing here, I'd like to thank everybody for their patience this semester. with getting the delivery of the material electronically. I hope you learned and retained a lot of this information. So, asbestos can cause health problems. Encapsulated is said to be safe. Tested theory, a longitudinal study was performed. There were 2 samples of office workers taken. The first, 23 workers in offices with encapsulated, had an average death of 72 years and a standard deviation of 5. In the second sample, 36 workers with no asbestos, average death was 75 with a standard deviation of 3.8. Based on this evidence, is there a difference in life expectancy at the 5% significance level? So this is a little different still. This time we're comparing the populations based on these samples. And we're just saying not equal to. We're not saying one is greater than the other. So they just want to know, is it different? So if they ask, is it different, that means it's a two-tailed test. Okay, and so when we draw our pretty picture this time, it's still a standard normal curve, but now we've got shaded on both sides, and we're going to have to use a t-test for this, because these are small samples. These aren't based on populations, and it's pretty small. So we have 36 for 1 over n, or 23. So to find the degrees of freedom, you always use the smaller of the 2 samples. You want to be more conservative. So 22 degrees of freedom. And so now again, I'm going to do the little paper. Let's take a look here. That is 5% significance level, two-tailed test, 5%, and now we follow it down to 22. So there it is, 2.074. Okay, so that, because we looked it up as a two-tailed test, you don't have to worry about, I've had students divide it. Don't divide it. Use 2.074 and use negative 2.074. All right, so we got the positive and the negative version. And now let's do our stuff here. We've got x bar 1 minus x bar 2 over, and then it's minus those, but that's just 0, so I'm not putting it in. It's this one minus this one, which always works out to be 0, because if they're equal, it's 0. So then the standard deviation of the first sample squared, so the variance basically, divided by the sample size, and the variance of the second one divided by the sample size of the second one. So what that looks like in numbers is 72 minus 75. Now it's a two-tailed test, so it doesn't matter if you put the 75 first minus the 72, because then you'll just either go into this one or go into that one. So it doesn't matter which one is first and second. I'm going to leave it like this. I put it as the first one was the first one that I read. All right. And so now we got 5 squared over 23. That's a 5, not an S anymore. That's a 5. And then plus 3.8 squared over 36. And so you might want to do all of this in your calculator first. Do the 25 divided by 23 plus 3.8 squared divided by 36, and then hit enter. Then take the square root of that. All right, instead of trying to get it all into 1. So when you do that, the bottom, the denominator will be 1.2194. The top is going to be negative 3. So when we divide that, we get negative 2.460. That is a t-score of negative 2.46. Let's see where that lands. Oh, we just had to beat 2.1 basically, and we got negative 2.5. So it's in there. And so this is what I mean. If you would have said it was 75 minus 72 and switched these around, it still would have been 1.2194 on the bottom, but you'd have positive 3 on the top and you'd just be here. And you'd be making the same conclusion. So either way is fine. Negative 2.46. All right. And so what does that mean? That means it's in the shaded area. So that was letter C. Letter D is reject the null. We circle that, and then we make our conclusion. We conclude at the 5% significance level. That the average death of workers with encapsulated asbestos differs from the average death of no asbestos workers. I'm sure a lot of you could articulate that better than I can. I know I'm not great at writing up conclusions, but you need the context of the problem. What were we comparing? Because this was this shaded area, we went with this. And basically, we're saying the mean age of death is different from the mean age of the other thing. So try to keep it kind of just the facts, okay? Don't throw in there, see, asbestos is killing people, I told you so. Nothing like that. Try to keep all of the voice out of it. Just report the findings. So you're restating this, you're restating that. All right. And that's it. That's stats for the year. I hope that you have learned some meaningful things in this course that you will be able to use in your very bright futures. Thank you again.